Hello everyone, I am Asha Rani, PhD student from IIT Jodhpur. I will be presenting our paper titled Activity-Based Early Autism Diagnosis using a Multi-Dataset Supervised Contrastive Learning Approach. A short introduction about Autism Spectrum Disorder. ASD is a neurological disorder affecting social interaction and communication of a person. Few recognizable symptoms include lack of eye contact, poor imitation skills, and repetitive behavior. Current mean age of diagnosis is between 3 to 12 years. And early diagnosis is crucial for early intervention, which can significantly benefit growth of the affected child. Traditionally, autism diagnosis has been performed physically by an expert medical practitioner. However, this requires multiple visits, which is a time-consuming process, and still there is a possibility of error in the diagnosis. Our aim is to automate autism diagnosis using videos. Our task is to obtain a good prediction accuracy with ML model, which is a challenging task because of the limited amount of training data available. Data complexity, low interclass variability in the video samples. In this figure, the top row is sample from ASD and bottom row is from control class. We observe that both the samples look quite similar and it is quite difficult to even distinguish between them with bare eyes. We present a data-driven approach for automated autism diagnosis by utilizing action videos recorded in a loosely controlled environment. This is a cost-effective and easier to acquire method in compared to traditional methods like EEG and MRI. The first step in our approach is generation of cross dataset pairs. In our task, we have two datasets D1 and D2. Both of them contains video from ASD and control class. During training, a batch consists of samples from both the dataset. For a given sample that is an anchor from one dataset, we create a positive pair by pairing it with a sample from the second dataset, which belongs to the same category. If the other sample belongs to a different category, then it is called a negative pair. The pairs generated in the previous step are then passed to a deep feature encoder network to obtain initial features, which is then passed to a MLP layer, which gives the final embedding Zi and Zj. We calculate M sub CL loss of a VA sample, that is the anchor sample. In the numerator, we calculate similarity between anchor and the positive sample. In the denominator, we calculate similarity between anchor and the remaining samples. The set Ka contains all the samples including Vp. Pa here represents set of all the positive samples with respect to Va. Next, we train a dataset specific classifier. Similar to earlier methods like SimCLR, we take only encoder network from the previously trained network. Then we add a new fully connected classification layer with softmax activation. We learn parameters for the network using standard cross entropy loss. This network is used to do prediction on test data. These are the methods compared in the paper. Binary classifier, SSCL, SoupCL all works on single dataset at a time. For SSCL and SoupCL, pairs are generated using augmentation, and SoupCL also uses label information. Multimodal SSCL takes up sample from the batch containing data from both the datasets, but the pair generation is done using augmentation, while our method takes one sample each from both the dataset and uses label information to create pairs. Datasets used. Hand gesture dataset. This comprises videos of 4 activities performed by 39 subjects, out of which 19 are ASD and 20 are control subjects. Autism dataset. This comprises videos of 8 activities captured from 2 angles, tutor facing and child facing, for ASD subjects. The control class was created by selecting similar actions from a publicly available dataset, HMDB51. Here we examine the classification accuracy of all the approaches on the challenging dataset hand gesture in table 1. By the results, we can infer that binary classifier failed to learn semantic characteristics. Compared to it, both SoupCL and SSCL perform better. Even without categorical information, SSCL outperformed SoupCL. This may be because of the inherent task-specific challenges in terms of small training data and low interclass variability. Multimodal SSCL performs poorly. Originally, it uses pair data. Here in our case, we don't have a pair data, so it may not work in such scenarios. Overall, our method performs best. In table 2, all compared methods achieve near perfect accuracy for the autism dataset. This may be due to the reason as Both the ASD and control subjects are acquired differently for this dataset, and both of them have a different distribution. Here, the first figure shows confusion metrics for all the approaches on hand gesture data. The binary classifier classifies most of the samples as ASD. It cannot distinguish ASD from control. SSCL and multimodal SSCL classifies most control samples accurately, while ASD prediction error is higher in case of multimodal SSCL and SoupCL. Multi-dataset SoupCL performs better than any other method for control samples classification, while SSCL performs well for ASD, which is comparable to MSoupCL, but it misclassifies many control samples. In the second figure, we compare the testnet distribution for hand gesture dataset, and for the two classes, MSoupCL has segregated the best. Here we analyze MSoupCL performance on hand gesture dataset using different hyperparameters. In first figure, model performance with varying batch size shows that the accuracy increases first and subsequently declines. This may be due to the presence of only two categories. Second figure shows the importance of feature embedding size. Initially, the accuracy increases with the increase in size, and then it starts to drop. In the next figure, we show the effect of temperature on the results. The lower the temperature value, it gives the better result. Qualitative analysis. The first row exhibits instances classified correctly by both the models. The middle row displays cases where MSoupCL correctly classified while SSCL misclassified. In the last row, sample is misclassified by both the methods. When MSoupCL predicts correctly, it has a higher confidence score and a low confidence score for incorrect prediction. However, SSCL has a low confidence score in correct prediction while a higher confidence in the misclassification. Overall, this analysis shows superiority of our method. To summarize, in this paper, we have used contrastive learning setup to integrate information from two independently collected and significantly diverse videos for autism diagnosis tasks. The multi-dataset supervised contrastive learning technique learns discriminative features and is beneficial for automatic healthcare related problems. Limitation of all the methods examined is that there are high false positive and high false negative rates. These are the references used for these slides. Thank you for your attention.